It's absolutely unsteady. It will detonate. No, giving me isn't going to be an astounding opportunity to go for that. The thing is, it very well may be tomorrow. It may be during this transmission. It would shine like a second sun over the James Webb Telescope. Actually, it has distinguished an amazing 250% increase in the brightness of Betelgeuse, the red star located at the shoulder of the Orion constellation. This erratic behavior has sparked excitement for a fascinating display. Some suggest the surprising increase in brightness could indicate that Betelgeuse is preparing to go supernova. Yet, the exact timing remains uncertain. Experts estimate it could happen soon. Join us as we explore the depths of space and unravel the mysteries surrounding this celestial giant. Betelgeuse could potentially reshape how we perceive the universe. Despite its name not being widely known, you've likely admired its beauty. A radiant reddish glow shining brilliantly at the shoulder of Orion, a prominent star in the constellation. Betelgeuse's size is staggering. If placed at the center of our solar system, its outer surface would extend beyond Jupiter's orbit. This massive star, easily visible, continues to captivate us. Unlike most stars, Betelgeuse varies in brightness over time due to its classification as a semi-regular variable star. Its brightness fluctuations suggest an eventual dramatic collapse in a supernova explosion. Recently, Betelgeuse has become even more fascinating due to extraordinary changes in brightness. These variations included a significant surge on May 20, 2023, when scientists observed an astonishing 142% increase in brightness, followed by a later update indicating a 150% increase. Andrea Dupree, an astrophysicist from the Harvard-Smithsonian Center for Astrophysics, notes that Betelgeuse now ranks as the seventh brightest star in the night sky, climbing from its usual 10th position. From the southern hemisphere, Betelgeuse shines brightly in the evening sky, distinctly visible at the shoulder of the Orion constellation. Dr. Sarah Webb, an astrophysicist from Swinburne University of Technology in Australia, highlights Betelgeuse's significance. It offers a unique opportunity to study the final stages of a massive star's life, providing invaluable insights into red giants just before they explode as supernovae. When Betelgeuse eventually explodes, it could become extraordinarily bright for about 7 days, possibly casting shadows at night. This prospect excites both amateur stargazers and professional astronomers alike. Heidi Morris, an expert at Los Alamos National Laboratory and president of the Pajarito Astronomers and Cosmology Club, noted the enduring interest in Betelgeuse's brightness changes, a phenomenon observed for centuries by various cultures. Currently, Betelgeuse's bright cycle lasts about 130 days, significantly shorter than its usual 400-day cycle. These rapid changes give astronomers a rare chance to study this stellar phenomenon in detail, revealing insights into the final stages of a star's life. The dramatic behavior of Betelgeuse began in 2019 when it violently ejected part of its outer atmosphere. These fluctuations in brightness are unusual for Betelgeuse, raising questions about whether it is nearing a supernova. According to a paper by Dupree and other researchers from Harvard and the University of California, Berkeley, it may take another 5 to 10 years before Betelgeuse returns to its typical 400-day brightness cycle. Since the Great Dimming, Betelgeuse's brightness and outward velocity have shifted. Despite its erratic behavior, Betelgeuse remains a massive red supergiant star undergoing the final stages of rapid evolution. As it exhausts its fuel, its core will collapse under its immense mass, resulting in a supernova explosion that could outshine entire galaxies. The timing of this event remains uncertain. Dr. Mark Smith, a professor of astrophysics at the University of Portsmouth, explains that predicting supernova events is challenging due to limited historical data and the complexity of stellar evolution. Betelgeuse is currently undergoing fusion processes, constantly evolving through elements like helium, carbon, oxygen, silicon, and iron. As a red supergiant, Betelgeuse fuses helium into carbon in its core, a process that takes thousands of years. Eventually, it will progress to fuse heavier elements until it can no longer sustain fusion reactions. This will lead to gravitational collapse and possibly result in the formation of a black hole or neutron star. While some speculate that Betelgeuse's explosion is imminent, Historical records indicate it has been reddening over the past few millennia, suggesting it may take a considerable amount of time before it goes supernova. NASA estimates that Betelgeuse won't explode for another 100,000 years, providing reassurance that its dramatic end is unlikely to occur within our lifetimes. Despite the uncertainty, Betelgeuse's behavior continues to intrigue scientists and inspire advancements in how we understand the universe. Dr. Sarah Webb reminds us to stay open to potential results, even as we perceive the unlikely possibility of seeing Betelgeuse's impact in our lifetimes. Remaining mindful of its progressions might prompt additional scientific breakthroughs, reminding us to keep hope alive for new revelations in the universe. It's crucial to comprehend that our perceptions of Betelgeuse are essentially glimpses into the past. The light we see from the star is over 600 years old. Speculatively, Betelgeuse could have already exploded, and we wouldn't yet know it. While this possibility exists, it is far from certain. History has shown us that assumptions in astronomy can be challenged. Before 1987, astronomers believed only red supergiants could undergo supernovae. However, that year a massive blue star in another galaxy exploded, shocking the scientific community. There is still much to learn, and surprises could lie ahead. Observing Betelgeuse and other massive stars allows us to expand our understanding of stellar phenomena. Despite the absence of an imminent explosion, Betelgeuse's current behavior is fascinating. Its oscillation between dimming and brightening reveals captivating physics. The fact that stars pulsate on human timescales is astounding. Currently, Betelgeuse is much brighter than usual, likely due to its typical multi-day cycle, and astronomers hope it will eventually return to this cycle. However, it appears to be struggling to do so. Recent observations suggest that Betelgeuse may be in a late evolutionary stage, nearing the end of its core carbon-burning cycle. This stage involves the transformation of carbon into heavier elements like oxygen and magnesium. If this is indeed the case, scientists predict a core collapse leading to a supernova explosion that could occur within a few years. However, the exact phase of Betelgeuse's development remains uncertain, and many questions persist. The possibility of witnessing Betelgeuse's explosion remains unclear. The carbon-burning phase can last up to 1,000 years, and studies suggesting an imminent supernova have not yet been published. Nevertheless, considering the potential for Betelgeuse to go supernova is thrilling. It would be a remarkable event, visible even during the day for several days. When the event occurs, the initial signs of the cosmic explosion will be subtle but definitive, with neutrinos sweeping across Earth and high-energy photons escaping from the expanding cloud of stellar debris. Betelgeuse will gradually grow brighter in the night sky, potentially reaching a peak luminosity 10,000 to 100,000 times its normal brightness within a few weeks. This spectacle will captivate anyone fortunate enough to witness it, marking a pivotal moment in cosmic history. The remnants of Betelgeuse's explosion could be as bright as a quarter or half of a full moon, compressed into a single point of light. Astonishingly, this brightness would be visible even during daylight, casting dramatic shadows at night. Predictions suggest it might be 15 to 20 times brighter than Venus, currently the second brightest object in the night sky. The display of Betelgeuse's explosion would linger for around 100 days, enchanting space enthusiasts and offering a unique opportunity to observe its aftermath up close. Fortunately, a Betelgeuse supernova wouldn't pose any threat to humanity, as it is still relatively far away. Telescopes and other optical instruments would allow us to study the event in detail without harm. Such a dramatic event would undoubtedly draw global attention. Historically, supernovae were often interpreted as omens, and Betelgeuse's demise could spark fascinating cultural responses worldwide. Astronomers believe it could even inspire widespread interest in astronomy, awakening people's curiosity on a global scale. Betelgeuse is not the only red supergiant in our universe. Others like Eta Carinae could explode before it does. Statistically, the Milky Way should witness a supernova roughly every 50 years, yet we haven't seen one in the last 400 years. However, remnants of past explosions indicate that we are overdue for a significant cosmic event. It's only a matter of time before the next star explodes for the universe to observe. Betelgeuse's history is rich with significant events, including the dramatic dimming in late 2019. This unexpected drop in brightness puzzled astronomers and sparked speculation about a potential explosion. Although Betelgeuse's brightness returned to normal by April 2020, the cause of its dimming remained a mystery until further observations shed light on the phenomenon. Skywatchers can easily spot Betelgeuse from their homes, making it an accessible celestial body to engage with. If a supernova occurs, we are sure to witness an incredible cosmic performance. As we continue to monitor Betelgeuse, the star remains a beacon of fascination for professional astronomers and amateur skywatchers alike. Its ongoing changes in brightness provide rare opportunities to study the processes occurring within a dying star. With advanced technology, scientists can now analyze the star's behavior with unprecedented precision. Instruments like the James Webb Space Telescope, alongside ground-based observatories, are unveiling more secrets about this stellar giant. The study of supernovae, like the one Betelgeuse could eventually become, has broad implications. Beyond understanding the end stages of a star's life, these explosions are critical for the formation of elements heavier than iron, essential for creating planets, life, and the universe itself. In many ways, the death of stars like Betelgeuse contributes to the very building blocks of the cosmos, enabling new stars and planets to form from the remnants of their exploded cores. Should Betelgeuse go supernova in our lifetimes, it would offer a unique and breathtaking opportunity to witness such an event up close. For those lucky enough to observe it, it would be an unforgettable spectacle. The light from the explosion would outshine all other stars, temporarily becoming a fixture in our sky while astronomers race to capture data. Interestingly, this potential supernova wouldn't pose a threat to us on Earth. Despite Betelgeuse's massive size, the distance between us and the star ensures that any radiation emitted by the explosion would have little impact on our planet. Instead, the supernova's influence would be most felt by scientists and space enthusiasts studying the phenomenon as it unfolds. This event could drive further advancements in space exploration, enabling more research into stellar evolution, cosmic explosions, and the mysteries of the universe. Regardless of when it happens, Betelgeuse's eventual explosion will be a pivotal event for astronomy, expanding our knowledge of star death and the life cycles of massive stars. The spectacle may also inspire future generations of astronomers, fostering curiosity about the cosmos and encouraging people to look up and marvel at the vast universe.